What you're seeing on your screen right now is a rough, high-quality diamond. But here's the part most people miss. Before this stone became a valuable crystal worth more than a luxury sports car, it wasn't shiny, beautiful, or impressive. It was trapped inside an ordinary, dull, ugly piece of rock, the kind of stone anyone would walk past without even noticing. And that creates a question that almost nobody asks. Which ugly stones actually have diamonds inside them? And more importantly, could you recognize one if it was right under your feet? Now imagine walking along a dry riverbed full of gray, cracked, lifeless pebbles. Nothing looks valuable, nothing looks special, until suddenly one single rock, darker, irregular, almost ugly, reflects the sunlight in a strange way. You pick it up, turn it in your hand, and for a split second, something inside it seems to sparkle. Is it possible that a rock that looks this worthless could actually be hiding a diamond worth tens of thousands of dollars per carat? As unbelievable as it sounds, this has already happened to regular people, in regular places. And the truth is that most diamonds discovered in nature were first found inside rocks that nobody would ever suspect of holding anything valuable. Most people believe that diamonds always look clean, transparent, or shiny when discovered. But in reality, nature hides them inside some of the ugliest rocks you'll ever see. Volcanic fragments, weathered boulders, and dull river stones that look like nothing. That's why so many potential diamonds have been kicked, ignored, or thrown away for decades. And here's the shocking part. Some of the most valuable diamonds in the world, especially those with strong colors like deep yellow or vivid blue, came from rocks so irregular and unattractive that most beginners would never pick them up. Even in the United States, places like Arkansas have produced diamonds found by ordinary tourists breaking open rough, unremarkable stones. So pay very close attention, because what you're about to learn can dramatically increase your chances of finding one of these natural treasures. In this video, you'll finally discover which ugly stones actually contain diamonds, how nature hides them, and the clues you must look for in the field. This is brand new content, a step-by-step look at how diamonds worth millions of dollars can be concealed inside rocks that look completely worthless, until the right eyes finally recognize them. To really understand why diamonds can end up hidden inside ugly, ordinary-looking stones, we need to travel back not just millions, but in some cases billions of years, and dive into a region no human has ever physically reached, the Earth's mantle. This layer begins about 100 miles beneath our feet and extends for thousands more, a place of unimaginable heat and crushing force. Down there, the pressure can exceed 725,000 pounds per square inch, and temperatures soar beyond 2,200 degrees Fahrenheit. In this furnace-like environment, a simple element, carbon, undergoes a transformation into one of the rarest and hardest crystals on the planet, the diamond. At the surface, carbon is common and soft. It exists as coal, as the soot of a candle flame, or as graphite in a pencil. But in the mantle, those same carbon atoms lock into a rigid, tetrahedral crystal structure. This atomic arrangement is what gives diamonds their famous durability, their incredible resistance to scratches, and their unmatched brilliance when cut and polished. Scientists believe that many natural diamonds were formed billions of years ago, making them older than most mountain ranges, older than the first trees, and in some cases, even older than life as we know it. Yet forming a diamond deep underground is only half the story. If they had stayed buried in the mantle, humans would never have known they existed. Nature needed a way to transport them upward, and that came in the form of extremely rare volcanic eruptions. But these weren't the slow, bubbling flows we see in places like Hawaii. They were explosive events that ripped through the crust with incredible force. Kimberlitic magma, rich in gases and minerals, blasted its way to the surface, acting like a geological elevator from the mantle. This incredible speed was essential. If the journey had taken days instead of hours, the diamonds would have reverted to graphite long before reaching the surface. That is why true diamond-bearing pipes, called kimberlites or lamproites, are so rare. The conditions needed to preserve diamonds are almost never repeated in Earth's history.
Thank you.
Once diamonds are locked inside kimberlite or lemproit pipes, time and erosion take over. For millions of years, the relentless forces of rain, wind, and rivers slowly break down the volcanic host rock. Each season, a little more is carried away until the diamonds inside are freed. Here's where water becomes nature's quiet treasure hunter. Flowing rivers act as a natural sorting system, carrying away lighter materials and concentrating heavy, durable minerals. Because diamonds rank 10 on the Mohs hardness scale, they resist being ground down or dissolved, surviving journeys that destroy weaker stones. Over thousands and even millions of years, these processes concentrate diamonds into what geologists call alluvial deposits. These are natural traps where heavy minerals settle out of the current. The best spots are bends in rivers where the water slows, behind large boulders that act like shields, or in depressions in the bedrock where currents swirl and lose energy. It's the same principle that causes gold flakes to collect in a prospector's pan. And in fact, gold and diamonds are often found side by side. Along with them, indicator minerals like garnet, ilmenite, and chromite often accompany the gems, serving as geological clues that a river may be hiding something valuable. This is why some of the most famous diamond finds in history didn't come from deep mines, but from river gravels. In Africa, Brazil, and even the United States, prospectors stumbled upon sparkling crystals in ordinary-looking sandbars. What makes it tricky is that rough diamonds don't resemble the cut gemstones in jewelry stores. They often appear greasy, cloudy, or glass-like, with irregular shapes and rounded edges from tumbling in the current. Many have been mistaken for quartz or discarded as worthless glass. To the trained eye, however, their unique luster and density set them apart. Think about the story every stone carries. Forged billions of years ago under unimaginable heat and pressure, shot to the surface in volcanic eruptions, eroded from ancient host rocks, and finally transported grain by grain until it settled quietly in a riverbed. The truth is, every diamond found in a gravel bed is a survivor of one of Earth's most extreme natural journeys. And if you learn how to read the river's hidden traps, you might just uncover one yourself. Now that you already know where diamonds come from and how they end up in rivers, before you even think about going out to search, you need to know whether the river you plan to explore can actually contain diamonds or not. The truth is, not every river has the potential to hold diamonds. And this is exactly where indicator minerals come in. Small geological signals that work like red flags pointing to promising areas. These minerals appear because they share the same geological story as diamonds. They were born at extreme depths brought to the surface by kimberlite eruptions, and over time, transported by erosion into riverbeds. Just like diamonds, they resist weathering and end up concentrated in the same accumulation points. If you find some of them, your chances increase considerably. First on the list is pyrope garnet. These small reddish to purplish stones, sometimes with a brownish tone, are classic indicators. They're denser than common minerals and concentrate in the same pockets where diamonds can be found. In the field, they stand out due to their glassy luster and intense color, even in small fragments. In many mining areas across Africa and North America, the presence of garnet was the initial clue that led to major discoveries. Another important mineral is ilmenite, an iron and titanium oxide. It usually appears black or dark brown with a subtle metallic luster. Although it's not a gemstone, its presence in alluvial deposits near kimberlite zones is considered a strong sign that diamonds may be nearby. Often it appears mixed with heavier gravel accumulated at the bottom of the river. The third key mineral is chromite. Black, opaque, and with a metallic shine, this mineral is heavy and resistant, easily surviving river transport. Geologists consider chromite one of the most reliable indicators because its origin is directly linked to deep mantle rocks, the same ones that form diamonds. If you find dark, rounded grains that feel almost magnetic due to their density, stay alert. It could be a strong signal. We also can't forget about chromium spinel. Although less known, this mineral usually appears in dark red or nearly black shades with a glassy shine. It's another typical survivor from deep environments and often shows up alongside garnet and ilmenite. If you find this trio gathered in a riverbed, the probability that you're in a diamond-bearing area increases significantly. In addition to those, there are accessory minerals that can also help, such as zircon, small transparent to brown crystals, very dense. Olivine, when it survives, it appears in greenish tones, and even magnetite, easy to test with a magnet. None of these guarantees diamonds on their own, but their combined presence works like a natural map, pointing to the right locations for prospecting. And here's a crucial detail. It's not enough to simply find these minerals scattered in the gravel. What really matters is the concentration. If you see isolated garnets every now and then, it might just be coincidence. But if your sieve, or even direct observation of the gravel, shows a large quantity of heavy minerals, especially garnet, ilmenite, and chromite, that means the current has worked like a natural filter, and that stretch of river is promising. Now that you already know how to identify the signs that a river might hold diamonds, it's time to understand how the panning process actually works. This is the stage where knowledge meets practice. You'll use the power of water itself to separate gravel and concentrate the heaviest minerals, and possibly diamonds among them. The first step is choosing the right spot. Remember what we've already covered: inside bends of rivers, areas behind large rocks, depressions in the riverbed, and natural cracks along the banks. These spots act like traps where the current deposits denser materials. There's no point in panning just anywhere. It's in these pockets where your chances truly increase. Once the location is chosen, the next item is your basic tool, the mining pan, also called a batey in some regions. It can be made of metal, wood, or even sturdy plastic. What matters is that it has a conical or rounded bottom, because that shape helps natural separation. If you don't have access to a professional pan, even a deep pot or a cut bucket can work, as long as it lets you swirl the material with water. Start by placing a moderate amount of gravel from the riverbed or banks into the pan. Fill it with water and begin swirling in circular motions. Physics does the work. While lighter materials, sand, clay, fragile fragments, get carried away, the denser material sinks to the bottom of the pan. This is the same principle nature has been using for thousands of years to concentrate heavy minerals. The key is in the rhythm of the movement. Too fast and you lose material, too slow and nothing separates. The ideal pace is steady and firm, allowing the water to wash the upper layer without disturbing the bottom. With practice, you'll notice the heavier minerals start to form a darker layer at the bottom, almost black, due to the presence of ilmenite, chromite, and magnetite. And it's within that concentrate where diamonds might appear. They usually show up as small, translucent, or milky stones with a bright shine, rounded by the river's transport. Unlike quartz, which tends to be less dense and more fragile, diamonds have a glassier reflection and can withstand the panning process without breaking. Here's a practical tip. Use sunlight at an angle. Diamonds often reflect light vividly, almost like tiny mirrors. Another simple technique is the oil test. If you wet the stone and gently touch it with your finger, you might notice that the diamond holds a thin film of water differently than other crystals. These are subtle details, but they can be the difference between a discovery and a missed opportunity. Of course, a diamond won't always show up right away. In many cases, the first things you'll find are actually the indicator minerals: red garnets, dark grains of chromite, or metallic specks of ilmenite. That's already an excellent sign that you're in the right place. Now that you know how to pan a river and concentrate the heaviest gravel, we've reached the part that separates those who find real treasure from those who unknowingly throw away a fortune, figuring out whether that shiny little stone is actually a diamond or just quartz, topaz, zircon, or even apatite, which are common river minerals that fool a lot of people. And yes, there are plenty of real cases where someone kept a rough diamond in a box thinking it was just crystal, or worse, tossed it away because it looked like river-worn glass. The first major enemy in identification is quartz. It shows up in just about every riverbed, whether milky, transparent, or smoky. And to an untrained eye, especially when it's been rounded by the current, it can be easily mistaken for a diamond. But quartz has a simpler luster, a glassy shine, while diamonds reflect light in a much more intense, almost piercing way. Another clue. Quartz often breaks into elongated points with hexagonal terminations. A rough diamond almost never shows that. It usually appears more irregular, with triangular faces or rounded shapes. A simple test is to scratch a piece of glass. Quartz can scratch it, yes, but the tip gets worn down. A diamond, on the other hand, scratches it easily and shows no damage. Another look-alike is topaz. It's rarer than quartz, but it does appear in rivers that pass through granite-rich areas. When colorless, it looks a lot like diamond, especially if it's been rounded by water and lost its original shape. But there's a catch. Topaz is a bit lighter. If you hold two stones of the same size, you'll feel the difference. Also, topaz tends to break along flat plains, almost like cracked glass. A diamond, however, is far more resistant and rarely breaks that way. If you observe carefully, you'll also see that topaz has a glassy luster, while a diamond has an adamantine shine, much livelier and sharper. Zircon is another one to watch. In rivers, it can appear transparent, yellowish, brown, or even reddish. It's a heavy mineral, so it often ends up in the same concentrate where diamonds appear. That's exactly why it causes so much confusion. One key difference, zircon tends to be denser. Often you'll pick up a small stone and notice it feels surprisingly heavy for its size, a clue that it's probably not a diamond. Also, look at the color. Rough diamonds usually have subtle shades, clear or slightly yellow, while zircon tends to show more saturated tones. If you have access to a UV light, use it. Many diamonds emit a bluish fluorescence, while zircon usually doesn't react the same way. Then there's apatite, not often mentioned, but it's very deceptive. It can appear transparent or greenish, always with a glassy shine. But here's the deal, it's much softer. If you take a steel knife and scratch apatite, it marks easily. A diamond, as you know, is the hardest of all and doesn't get damaged like that. So if the stone scratches too easily, forget it. It's not a diamond. Apatite also tends to break in clean flakes, while diamonds are incredibly resistant and don't split that way. Now let's talk about a few simple tests that anyone can do right there at the riverbank. First, the scratch test on glass or sandpaper. Quartz scratches but leaves a mark. Diamonds scratch without damage. Then there's the water or oil test. Diamonds tend to hold a thin film on the surface, almost like they're oily, unlike quartz and topaz, which feel dry. Another trick is to place the stone over a newspaper. If you can clearly read the letters through it, it's probably not a diamond, because diamonds disperse light so strongly that they block the image. And if you have a small UV flashlight, even better, many diamonds glow blue under UV, a reaction very few stones can replicate. But the truth is, in the end, identifying a rough diamond takes a trained eye and practice. It's not that perfect gem you see in store windows. Often it'll be rounded, dull in color, even unimpressive. And that's exactly why so many people kick diamonds off trails or leave them forgotten in drawers for years. So don't rely on intuition alone. Use these tests, pay attention to every detail. And remember, a diamond always stands out for its brighter shine, unmatched hardness, and that distinct feeling of holding something different, even in its raw state. So next time you find a suspicious little stone in your pan, don't throw it away. Run the test, look closely, because what you're holding might just be a real diamond, the stone you always dreamed of finding. When we talk about diamonds in the United States, the first name that comes up is Crater of Diamonds in Arkansas. It's not just a tourist park, it's an exposed volcanic pipe where the primary material has been weathered at the surface for decades. What many people don't realize is that outside the plowed area of the park, water does the job that shovels don't. Rain and runoff redistribute the gravel, concentrate heavies, and form pockets in bends and depressions. That's why people who understand drainage don't just look for where to dig, they look for where the water has left behind unturned gravel. Dark streaks, pockets behind large boulders, and temporary channels formed after storms. That's where both tourists and prospectors have pulled diamonds straight out of the gravel. No drills or excavators needed. Moving up into the interior highlands, there are scattered reports along the Colorado-Wyoming border in areas with known kimberlite intrusions. It's not a roadside attraction with a big sign. We're talking about small creeks draining ancient rock zones. The successful stories always follow a pattern: mature gravel, well-rounded river stones, and a concentrate of heavy minerals when you pan. The method used there is the same: concentrate, observe for garnet and ilmenite, and if the heavy bag starts to appear, keep going. It's not glamorous, it takes patience, and not many people do it, but the reports are real. In Northern California, especially in stretches of rivers that cut through ancient fossil riverbeds, there have been finds linked to old channels. These channels may have been buried and later re-exposed by erosion or construction. When that happens, the gravel has had thousands of years to accumulate and form a very stable concentrate. Experienced hunters look for exposed layers in road cuts, hardened gravel beds, and bars of well-rounded pebbles, all signs that hidden material might be present. It takes technical work, not a quick hunt, but when the geological window opens, the results can be impressive. The logic shifts slightly when we look at the Great Lakes region. There, the agent of redistribution wasn't just rivers, it was glaciers. During the major glaciations, ice carried rocks and sediments hundreds of miles, mixing diamond-bearing material from the north with local sediment. When the ice melted, rivers and torrents reorganized that glacial legacy. That's why in states like Wisconsin and Michigan, heavy mineral concentrations sometimes show up in bars and bends of fluvio-glacial plains, and with them, rare reports of grains that, once examined, turned out to be something special. It's not common, but it's plausible, especially in areas where the regional geology suggests a deep mantle origin for the material. In the Appalachians, where gold prospecting has a long history, there are old reports of diamonds found alongside gold-bearing gravel. That doesn't mean every river with gold has diamonds, but the density-based concentration process is the same. In old rivers with stable bars and coarse cobble beds, heavy gravel tends to build up. Those who were panning for gold and saw lots of garnet knew to double their attention. The discoveries were rare, but consistent enough that local prospectors learned to evaluate gravel with a new level of scrutiny. Turning these stories into real action takes three simple things: a geological map, a good read of the drainage system, and respect for local rules. First, choose areas with records of kimberlite, lamproite, or glacial history that could justify the transport of deep origin rocks. Second, mentally trace the path from the source to the river and identify trap points: inside bends, pockets behind boulders, depressions, and old terraces. Third, confirm it in the field. If your pan starts bringing up garnet, ilmenite, chromite, and zircon in numbers, you're in the right corridor. And always do it legally. Many stretches are private land, parks and reserves have restrictions, and some areas require permission or a small fee. Respecting the land and asking for authorization avoids headaches and keeps prospecting sustainable. If we had to pick a starting point, the logical route would be Arkansas, because the system there is simple and allows for quick learning. Then move on to small creeks tied to more discrete kimberlite bodies, Colorado, Wyoming. Inspect exposed cuts and channels, Northern California. And for those living in the north, check out river bars left by glacial melt. In all cases, the story is the same: patience, a pan, and trained eyes looking for the signs of heavy gravel. Now let's suppose you've already found one of the stones we showed in this video. It's in your hand, it shines, it looks different, but at the same time it resembles other common river stones. Even if it looks very similar, how can you know if it's a real diamond? And if it's not a diamond, how do you figure out what it actually is before selling it or getting tricked? After all, it could be a colorless sapphire, a transparent topaz, a high-grade quartz, or even zircon, all minerals that many people confuse very easily. And that's exactly where most people go wrong, because without proper identification, you could end up selling a rare stone for pocket change, thinking it's worthless. That's what happened to one of our subscribers. Years ago, he found a strange little stone while swimming in a river with his family. He kept it in a box, assuming it was just quartz or some random crystal. One day, a shady acquaintance asked to see it, recognized what it really was, and bought it from him for just a few bucks. Months later, that same guy came back showing off the stone, now cut and polished. It was a high-quality zircon, valued at thousands of dollars. Imagine realizing you gave away a small fortune simply because you didn't know what you had. This kind of thing happens all the time, and that's exactly why we're here. Because the truth is simple. People who recognize the signs can turn an apparently worthless rock into a real asset. People who don't hand over the treasure to the first opportunist that comes along. And that's why we created the book Gemology Journey for Beginners, now available on Amazon. It brings together the key field tests we've shown in our videos, explained step by step with photos and comparisons. You'll learn how to identify gemstones using at-home tests, analyzing texture, density, luster, and hardness, all without needing expensive equipment. But if you're not ready to grab the book just yet, you can still subscribe to our channel for free and take advantage of the next videos coming up. In fact, in the next video, we'll reveal another natural environment where valuable gems have been found, unexpected places hiding incredible geological secrets. If you thought ancient rivers were surprising, wait until you see what we've prepared. Thanks for liking and subscribing. Good luck, Gem Hunter!